Hello class, I want to welcome you back. Today we are going to study elements and periodic tables. So after the discovery of atoms and the subatomic particles, it was observed that each element has unique number of protons in its nucleus. And the number of protons in the nucleus of an atom was called atomic number. And the elements were arranged in the periodic table in order of the atomic number, because the atomic number, the number of protons, determines the element. So when you change the number of protons, you change the elements. So each element has a unique name and symbol. And the symbols may be 1 or 2 letters. So the number of protons defines the element. So when you change the number of protons, you have changed the element. So for example, this is helium. All helium have 2 protons. And all carbons have 6 protons. You change the number of protons, you change the element. So you can see the periodic table. You can see some elements. So some symbols are 1 capital letter. Please take note. An element that has 1 symbol, it must be uppercase. It cannot be lowercase. And when an element has 2 letters, if the symbol of the element has 2 letters, the first letter must be uppercase and the second letter must be lowercase. You cannot have an uppercase, 2 uppercase as a symbol of the element. No. And if it has just 1 letter, it must be in uppercase. So some symbols come from elements' name, like carbon. Others come from Latin names of the elements. For example, Au for gold is from its Latin name aurum. You have copper too. Copper, its name is from copper, its Latin name. We want to talk about isotopes. Isotopes of an element have different number of neutrons, but they have the same atomic number. That's why we know that is an element. It's a particular element. Therefore, isotopes of an element have different masses, but have the same number of protons. For example, chlorine has 2 isotopes. One isotope has a mass of 35 atomic mass unit, and the other has a mass of 37 atomic mass unit. You can see the chlorine isotopes here. Isotope 1, number of protons are the same. You see them? That's why we know it's chlorine. But the number of neutrons are different. Isotope 1, which is chlorine 35, has 18 neutrons. And isotope 2, which is chlorine 37, has 20 neutrons. So isotopes, the percentage of an isotope that's present in an element is called its natural abundance. So in a sample of chlorine, if you take a sample of chlorine, 75.7% of chlorine atoms have the mass of 35 atomic mass unit, and 24.23% have a mass of 37 atomic mass unit. So the mass we see in the periodic table is the weighted average of these two isotopes, chlorine-35 and chlorine-37, is the weighted average. We're going to see how that is calculated. So we want to see how isotopes are represented. The atomic number is represented as Z. The mass number is represented as A. And the syllables, the symbol is represented as X. Isotopes can therefore be represented as follows. Let's look at some isotopic notations. We call them isotopic notations. So we can represent an isotope like this. You see, this is the symbol and this is the mass number. Example, this is chlorine-35 and we can have chlorine-37. This is one way of representing an isotope. A second way of representing an isotope is like this. You see, this is the atomic number, this is the mass number, and this is the chemical symbol. But what is the mass number? Mass number equals to number of protons plus number of neutrons. That's mass number. So we want to calculate the mass of an element. We want to calculate the mass of an element. For any compound that has isotopes, the mass is always the weighted average. This is what we see in the periodic table. And this depends on the natural abundance of the isotopes in the sample. For example, our chlorine has two isotopes, chlorine-35 and chlorine-37. We have seen their percentage abundance. So let's calculate their atomic mass, the one we see in the periodic table. So this is the formula. The average, we call this the average atomic mass. This is the mass we see in the periodic table. So is the fractional abundance of the isotope times the mass of the isotope. So this fractional abundance is what we call the percent abundance. So this is the percent abundance times the mass of the isotope, and this is that for chlorine-37. And when we do that, you see, the periodic table, this is what we see in the periodic table. So for any compound that has isotope, the mass is always the weighted average, as we have said. So this is chlorine again. We want to look at copper. Let's calculate for copper. We can see two isotopes in copper, copper 63 and copper 65. The percentage abundance of copper 63 is 69.17%, and the percent abundance of copper 65 is 64.9. So if copper is 69.17% copper 63 with a mass of this, and the rest is copper 65 with a mass of this, find copper's atomic mass. So we want to find the atomic mass of copper. So we are going to use this equation. So I'm just going to do it. So atomic mass equals to, we have percent of copper 63 is 69.17 for 100 times 62.5396 atomic mass unit plus 64.9278 atomic mass unit times, we need the percent of copper 65. So let's do the calculation. So 100 minus 69.17 equals to, we're going to write it here, 30.83 over 100. So let's continue. So this is 0.69.17 times 62.9396 atomic mass unit plus 64.9278 atomic mass unit times 0.3083. So let's do our calculation. Let's calculate. 0.6917 times 62.9396 equals to, we have 43.53 atomic mass unit plus, we have 64.9278 times 0.3083. That will give us 20.0172 atomic mass unit. So we are going to add this. So 20.01724 plus 43.5353 equals to 63.55 atomic mass unit. This is what you see in the periodic table. So that's what you're going to see in the periodic table. So that is so this is the percent abundance for copper 63. We have to find that for copper 65, which is, we got it as 30.83%. So the atomic mass is this and this plus this and this, and our answer is 63.5. So we can practice this. Using a periodic table, write down the mass of neon. B. Use the information given in the table below. Calculate the atomic mass of neon. So let's look at the periodic table and get the atomic mass of neon. So what is the atomic mass of neon? The atomic mass of neon is 20.18 atomic mass unit. That's what I got from the periodic table. Then let's try and do this one. So average atomic mass, we'll just do it here. We'll just try and do it here. So we have the mass of neon 20 is 20. So 20 atomic mass unit sorry, let's get back. I'm just trying to find space to do this. Let's try and do this. So let's get this. So mass, atomic mass is equals to 20 times, we'll find the percent of this, which is 0.9047 plus 21 atomic mass unit times, take note that thing is 0.27 divided by 100. So it gives us 0.0027 plus the next one is 22 atomic mass unit times 9.24 divided by 100 is 0.0924. So now let's do our calculation. So we have 20 times 0.9047. So it gives us 18.094 atomic mass unit plus 21 times 0.0027. That will give us 0.0567 atomic mass unit plus 22 times 0.0924. That will give us 2.0328. atomic mass unit. So our atomic mass is 18.094 plus 0.0567 plus 2.0328. So let's do that. Plus 18.094 plus 0.0567. So we have 20.1835 atomic mass unit. You see, it matches what we have in the periodic table. So that is how the atomic masses are obtained, which we have in the periodic table. So let's take another example this time. It said how many protons, electrons, and neutrons are in an atom of these isotopes of chromium. So that is the isotope of chromium. This is the mass number. This is the atomic number. We know that atomic number equals the number of protons. So this will give us 24. In a neutral atom, the number of electrons equals the number of protons. So this will give us another 24 for a number of electrons. So our mass number is number of protons plus number of neutrons. So the number of neutrons is therefore mass number minus number of protons. And when that is done, our number of neutrons is 28. Let's try and do some work on this table using the knowledge that we have. So class, we have 6 protons. So what number of electrons, what is the number of electrons? An atom has the same number of protons and the same number of neutrons. So this is 6. What is the atomic number? Atomic number is the number of protons. So this gives us 6. And what is the mass number? Mass number is number of neutrons plus number of protons. So we have 6 plus 7, which is 13. And what is the symbol of the element? So we said the number of protons determine the element. So the element with number of protons 6 in our periodic table is carbon. That's the symbol. And it's uppercase. So please use that to complete this table and practice it. The next thing that we want to look at, we want to talk about ions. Ions. When an atom gains or loses electron, it becomes an ion. So if a sample has a neutral charge, it is said to be neutral. So we just write the symbol like this, symbol of the element. But if a substance has a charge, it is called an ion. If the charge is negative, we call it an anion. If the charge is positive, we call it a cation. So we'll take some examples. This is fluorine. It has gained an electron. It's an anion. Sulfur, it gained 2 electrons. is an anion. Anions are named by changing the ending of the name to IDE. So for example, fluorine, this is its name. We are going to change this N to become fluoride. Sulfur is an anion. It becomes sulfide. We just change this UR to IDE. So that is how we name monoatomic anions. We'll talk about cations. Cations are formed when an atom gives up an electron. So for example, sodium has given out sodium 1 electron, and beryllium has given up 2 electrons. So cations are named by simply adding ion in the name of the element. So this is sodium cation. It is called sodium ion. This is beryllium cation. We simply call it beryllium anion. Beryllium ion, sorry. So that is how we name monoatomic anions and monoatomic cations. So practice, you can use this practice. I'll just do the first one. Atomic number 16, number of proton, of course, is 16. So we have, it is said it has 18 electrons. So what is the charge? Of course, it's -2, because the number of electrons are supposed to be equal to the number of protons. But now we have extra 2 electrons. So what is the symbol? The atomic number determines the element. And the element with atomic number 16 is sulfur. Because it has a negative charge, we put 2-. I'll do this one, then you can do the second one. So the number of proton is 12, so the atomic number here is 12. The charge here is +2, so this should be 10. So what is the symbol of the element? Atomic number, what element has atomic number 12? It's magnesium. 2+. So you can complete these other ones. So we will summarize this area of isotopes, elements and isotopes. Thank you again. We'll continue.